let's start recording again. All right. So we've got the point comparison complete. We've got the game up and running again. There's a couple of things that we still need to do, and then we're pretty much there, right? Then we're done. So these functions, these C functions that we're seeing here, we've create projectile, get position XYZ, get fraction complete. We can cache those too. And where are they, you may ask? Well, they are, let me do this in one go. Unit get position XYZ is global.moho.unit_methods.get position XYZ. And this seems a bit unintuitive, so let's look at where we actually got this from. Well, if we look at the unit class, then we can see that the class inherits from a table called moho.unit_methods. So moho is the name of the engine that we have. From my ID, am I recording? Yes. Am I actually hearable? Yes. Okay. And moho is not defined in this file, so it's part of the global table. And unit methods is all the C methods that we have. So now we can do, instead of saying and doing this, right, because that was syntactic sugar, instead of doing this, we can just say that. And then we prevent another table creation. Same thing with create projectile. I just don't know if that is a unit or an entity.
It's an entity.
It's an entity. Right. So then we have a local entity create projectile is g.moho.entity methods, I think. So let's check that to be sure. We go to entity, and here we see moho.entity methods, so we thought right. Entity create projectile. So with that we can fix this one, switch that one out. These were already upvalued. We can remove this to do. Then we've got another get position XYZ here. We already did that one, so let's replace, copy that. Ta-da! Another upvalue. Get fraction complete, that is a unit function. So yes. Unit is g.moho.unit methods.get fraction complete. So there we have it. Boink, boink, boink. There you go. And then we can remove these to-dos. We have a set velocity here, which is in this case the projectile instance. So let's get that one too. Local projectile get velocity g dot, I'm actually not entirely sure. Projectile. Projectile methods. Projectile.
That velocity?
Yeah, is that
That velocity is
yes.
Indeed, yeah, projectile.
Okay, so we've got this moho.projectile.get velocity. All right, And we can do this a bit further because this is a loop that's probably going to loop for quite a while. So we can even cache these as a local.
Yep.
Just like that. And we can cache the warp in here too. So that's all the functions. Cache, store as locals for performance. Flip direction is true. Let's make that part of the Alright, and now we've got one more thing to do. But before we do that, let's make a new engineer. Our factory just disappeared. And let's quickly do this. Oh, beautiful.
Why did his beam stop moving?
That's a very valid question. This is supposed to be set velocity, I suppose.
Yes.
Yeah, it's 10 out of 10. But you know that the error could have been in the maps. That would have been worse.
It's not.
Alright, let's see what we have. Ah, beautiful. Access to non-existent global projectile get velocity, because by all means I didn't rename it. Huh?
It's a question for further study there about bringing those values local. Bringing those functions local. At that point, you're elevating them from their up value status.
Yeah.
Right?
Yeah.
Yeah.
And I think the only moment where that is worthwhile is when you're doing it right in front of a loop like this one. That's
yeah.
because the difference in practice is so small because of the time that it takes to allocate this is
Yes.
relatively large.
And some functions are more impacted by it than others.
Yeah. All right. So that's essentially everything that we can do inside this function. So let's scope out and look at this UEF build 01 underscore projectile. We already scoped it in terms of that it's this little projectile. So we're just gonna copy that from the base game into our there we go, and let me put them in. Whoa, my voice went. There we go. Into UEF build and UEF build effect. Whenever you introduce new files, you gotta restart the game. Even though it says it noticed a change, it didn't. So we're just gonna restart it. All right. And there we go. Let's go back into Cetans, the only viable map in this game. I like how long it took for that loading tip to load in.
Isn't Seaton's where they keep the eco manager and the blinking lights?
Yeah, they keep it in the water until it stops blinking. Sorry. That's horrible of me to say. Let's look. Yeah, I think that's pretty much it. Alright. Meanwhile, the game loaded. And for those wondering, is this the laptop you play on? Yes. And now leave me alone. Alright, so everything is working. Let's make sure that our changes are in effect. So if we now do on create is function self comma spec, and this is actually not really relevant. Log I was made. So let's look at this. Clear out. I was made. But by all means, the effects are gone, right? So let's look at what we're going to do here. First of all, this class hierarchy that we're introducing is pretty complicated, right? We've got the emitter, then we've got the projectile itself, and the projectile itself is pretty big, and we don't need all this logic. So we've got this new projectile, which we called the dummy projectile, and we're just going to use that. So we go here, and then we type in projectile, that's this file right here, and we go for the dummy projectile. And now we have the issue that the effect didn't spawn yet. And that makes sense because the effects are spawned right here. So let's copy that in, put it in here. This is fx trails. fx trails, we're not going to make this part of the meta table, but we're just going to store this as a up value right there. And then for each of these, we're gonna do this effect, but we're gonna unloop this. So we're gonna grab this. We're gonna remove that. And we're just gonna say, well, you know, this is one of them. That is the other one. So now we have no table at all. And these fx trail scale and fx trail offset, as we saw in the original definition that we had, they were not defined, which means that they were using the definition that we have given here as a default, and those are 1 and 0. So we can essentially remove the scale because it's 1, and we can remove the scale and the offset here because they didn't matter. So we reduce it to this, which we can optimize even further because we can make this an up value. And then we have a new fancy UEF built projectile script. So let's look at that. Beautiful.
It's the baggage-free projectile.
Yeah, but
your Y value looks a little wrong.
Yeah, I agree. But that has nothing to do with the projectile.
No.
That has to do with the Y value computations.
Not the math.
No.
Coming down.
It's
coming down.
It's coming down. Yeah, it's just.
Yeah, it's just not in sync with the build queue.
Yeah, there's a minor. But yeah, the effects are there.
Yeah.
That's the important part here. So let's just.
Yes.
Alright. So what we did now, and that's a bit important to understand, we did more than it looks like, because we skipped the large meta table that we have here. We skipped this onCreate because we're not really interested in all of this logic. We skipped the onCreate here of the dummy projectile because we're not interested in all of that logic. We skipped a lot of logic in here, right? Because it tries to scale it with 1, right? That's what it does right there. And it offsets it with 0, which means that nothing's offset. But they were being called. We removed the for loop, and we removed this function call to the base class. Right, so all in all, if we compare this change to the other changes we've made, this is a pretty significant change, right, where we skipped a lot of the logic that we were having. And in particular, we skipped, for example, the table allocation that we have right here, and the fact that we set its health, and that we do these two checks. So that's pretty good. That's another small change, given the fact that this projectile is going to get destroyed and created a lot of times. Now let's quickly look at why our pull beam is doing that. I don't think that has anything to do with the projectile. Mash. What if I just remove that? No, that was too easy. Alright.
Sorry, I don't like to see you guess.
Aw, you know where it's going wrong?
No.
Oh. FY OY.
I think you're looking right at it. Get fraction complete has something to do with it. It is coming down based upon the fraction complete.
Yeah, but it's not at the end, or is the distance getting smaller and smaller?
Yeah.
Oh.
Well, the fraction's also getting smaller and smaller.
Yeah, you look at what you're using for your intermediate FY. Don't you want FY2 and FY1?
Hold on, I've got git diff. No. Let me think. Fy was center plus that, and we removed that from it. I'm not seeing it.
Okay.
Is it here
I
though?
didn't fall. I think it's there. I think you're looking right at it. I'm just not sure how your interaction works with it.
What?
There's the FY. I would have expected to see FY1, not FY.
Oh yeah, but the y distance is always the same.
Yeah, I see that. Yeah, but you've already done something with it there. Okay.
So
I wouldn't get too hung up on it. I mean, you can sort it out later.
yeah, I can sort out later. Yeah, you're right.
Yeah. It's just offset. It's going to look a little odd. Somebody will undoubtedly go, "Oh, it's all totally broken," but you know.
Yeah, yeah, but I'll fix it. I just gotta look at the git diff and then I'll find it. But that's, I think, it.
The projectile change is huge.
Yeah, that helps.
Every entity we add to the game carries around a substantial amount of baggage with it, including projectiles, and this one really takes an awful lot of data out of the projectile.
And it's a projectile that is being used a lot throughout the game, right?
Absolutely.
Imagine this scenario, and this is very common. Say we have 50 engineers, and then we've got this beautiful naval factory right there.
Yeah, absolutely.
And then we do something like that, and we do something like this, and then we suddenly have a paragon in the waters. Right, this is your typical Seasons game. And every time this frigate finishes and is made anew,
all those projectiles got destroyed.
And remade. So that's how common. That's why this is a pretty big change, but it doesn't appear to be that big from the fact that it's just one line of code.
Have you considered?
No.
Okay. All right.
Yes.
Well, I'm just wondering whether there's some possibility that we could create the projectile for each engineer once.
Yeah.
And house the projectile on the engineer so he never destroys it.
I have considered that, in fact.
Yeah.
And it's a bit hard to measure the exact impact, but what I did for the Cybern build beams is exactly that. So they have one engineer, one entity.
And it's kept through the duration.
Yeah, I think it was. So here it is. So beam end bots.
Right.
It's beam end and beam end builder. So we keep that entity alive so that we don't have to kill it.
Right. So you would for the engineers, I was just perceiving that you could create the projectile when the engineer is created, and it's basically it's hidden inside the engineer or attached to him, and then he just deploys it when he goes into build.
Yeah. So you would have something like this.
Yeah, I don't bother exploring that now. That's for later. I know you're not intending to do that. I just wondered if you'd consider it.
I think it is. I think it may be worthwhile. It was worthwhile if we didn't do this, right? Then it would be way more worthwhile. Self.army is nil, by the way, in this case.
Could we see the difference in the
Yeah.
byte code?
Yeah, let's do that. But I gotta fix this. Army is self get army. Gotta fix this real quick. All right. Good question. So let's stop my infinite frigate production, and let's look at the difference in the byte code. And the important part here is that we only have to list this one, right? Because we're not using that one anymore, and we're not using that one anymore. So now I need to have engineer create. There you go. Boop, 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 boop. Doink. Alright. So let's look at it.
Well, you can see it in the table list on the right, yeah.
For once, it's shorter. There's less instructions on this side than there's on this side, which I wasn't expecting because we added all that arithmetic. But that's one. Let's look at it. We've got get global, get up value, get. Is there actually a get global in this list? No, there's not. Right, so we're always getting up values instead of globals. Someone's keyboard is being very omnipresent. Skeptic, can you mute yourself?
Yeah, sorry.
So let's see if I can do a triple split. Boop, 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 boop. There we go. Beautiful. You there.
Well, know that if the stream stops suddenly, your laptop has exploded.
Yeah. That's give or take what happened then, yeah. Alright, so let's look at this. So by all means, the line numbers, which is this first digit, no longer applies because we moved everything, right? Because of these introductions right there. But let's look at it. We've got some get up values, which is this vector cached. We've got a get table, which was this get global initially, right? Because we did this get global self call, which was the get blueprint here and the get position. Instead of that, we have a get up value and then a get up value. That's sweet. We've got this entity projectile create again and get up value. By all means, we have some load case here, which is the strings that we have here on the right. Right, so that and the 0, 0, 0, nil, 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 nil. Apparently, there's a special load nil. I wasn't aware of that, but that loads all these nils in at once with one instruction, so that's pretty sweet. This call self move call, that's this trash bag thing that we had. right? So that's the self move call, where in this case we just have a get up value move call. So we skip the self in this case, and we skip it for a get up value. Note that the self essentially contains a get table and a move. So this move here is inherent in that self. Yeah, I'd say it's pretty decent, especially considering that this is a lot of get globals and tables. Look at this beauty right there. This was that table of vectors with.
Is that the mesh extent?
No, this is. Let's see. Yeah, this may have been the mesh extents. Yes.
Yeah.
It's about in the same range. And here we've got the bunch of new table with a length of 4, right? This is what Sprouter was talking about. We're creating a table with a set length.
Hey, Jip.
Yeah.
I don't mean to interrupt, but
yeah.
I noticed a while back. You see, like OX, OZ, and OY are all set to build extents X. Was that intentional?
No. But that explains.
I'm wondering if that has anything to do with our little Y problem.
Yeah. That has definitely something to do with it. Let me.
Because yeah, you just totally just overwrote all of them. I thought that was intentional, but I wanted to ask you about it.
Yeah, this is. No, what? Did I
well,
say?
you also did it wrong again.
Oh,
You said yeah, so that's Z, and then the other one's Y.
Yeah. This is unbelievable.
No, don't worry. I understand, dude. You're doing it on the fly.
It's not like we can fire you.
No, that's a good point. Beautiful. It's fixed.
Yes.
Okay, that's well spotted. I actually didn't see it while I was scanning it, so that's interesting. Good spot. Nice.
I've been trained very well.
But here we have to continue. So this was the build extents calculations, right? And now here we just have a bunch of get tables right there, right? So that's significantly shorter. Note that the line numbers here are very interesting, right? So we've got get table, test jump, get table, null. And this is one line, whereas here we have one line get table, one line get table, one line get table, etc. Alright. Then we've got this whole block of locals, which are actually no instructions at all, right? Because what the static analysis, the compiler does, is it computes the number of locals in the function, and it just allocates enough stack space to have all those locals in there. And that's why here you see line 97, which is... Did I change something? Get table. Load nil. Slightly confused. We see a multiply. That's this bit. And then here we see that jump, right? 111, which is right here, where we get a lot of nils. And then we get this up value again. So all these allocations are done with one instruction right now, with this load nil, which is pretty sweet. Alright, meanwhile, this is the get global, which is the vector list of 4 elements. Then we had set list 2. I have no idea what this does. But here we had the function call with this bit, right? This bit right here. That's what's happening right here, where we have a for somewhere, I suspect, a jump, a T4 loop right there. That's the for loop that we see here. With a get global, which is the table, with a move, that's the arguments, a call, which is the remove. So all in all, you see a lot of table stuff going on in here, and get globals and tests and jumps. Whereas here, it's just a bunch of arithmetics, a test, arithmetics, a test, which is pretty sweet. Right, this is really fast for the processor, whereas this is a lot of memory management or digging through memory and stuff like that, which is not very fast. And then we get to the point where we do this little bit here, and yeah, let's see what we have. Get up value 185. Oh, that's these. But all in all, I think this is pretty good. Given that we got rid of all the get globals, we got rid of a lot of self calls, we got rid of all these table operations that we were doing here with all the additional function calls. We got rid of these, right? We got rid of this one. We have 80 less lines of bytecode. So that's pretty decent. And we can do some more stuff, but then the code becomes a lot less readable. For example, one could argue that we don't need to compute this value unless absolutely necessary, right? Because if A is chosen, we just need A to do the check. So one could argue that we don't need this, but this doesn't particularly make it more readable. Not that this is very readable, but it's more intuitive, I suppose, than getting this into there. Yeah, so that's the finishing up part. And I think given the fact that we've already been sitting for 2.5 hours, I think that is fine for tonight. I'm just gonna stage this. Good stage.
I'd love to know what the actual performance increase is.
Yeah, so in this case, that's a bit more difficult to measure. I can do a comparison by having 500 engineers do it. But the problem is that there's a lot of initial logic, right? That's this bit. And once that's complete, it's just this loop right here that continuously pollutes the simulation. And this is not the heavy lifter, between quotation marks. Everything that was happening beforehand was the heavy lifter. But that's a one-time event.
Oh, I see what you mean. Yeah.
So I don't know how to test that in this case. But we could do a quick comparison. I'll spawn in 500 engineers and we'll see. Optimize. Oops, I did something dumb. Yeah.
Jib, if you're tired, we don't have to do this now.
No. I've got energy left for 5 more minutes.
Okay.
There we go. Good push. Actually, we can't do it because my laptop is currently spiking up and down with its gigahertz. Right? It's gonna go.
Do you not have a desktop?
Well, yes, but I'm not at home right now.
Ah, okay.
So any comparison we make is gonna depend on this number and not necessarily on what we did.
Yeah, I understand.
So we'll look.
And getting real world examples are much more telling. I mean, these situational tests of the speed will show a dramatic improvement in this particular aspect of performance. But remember, there are thousands of other things like these two functions going on out there that aren't optimized yet.
Yeah,
exactly. So
whatever gain you realize here is quite likely to be drowned out
by the rest.
By the rest,
which we're gonna tackle too, right? But one step at a time. and then at some point
Well, I think most important is the methods that you've demonstrated here.
Yeah, I agree.
The upvaluing of global functions and the way memory management can have a huge impact upon not only the size of your stack and your memory usage, your garbage collector, but everything is involved.
Yeah. I think that, and I think the bytecode comparison by all means it's a bit hairy to actually read and understand, right? But I think this shows already, given that we have a huge list of multiplications here instead of all the garbage that we have in here, already
Absolutely.
shows that this is way faster.
Even if you just glaze your eyes over and look at the length of the byte stack, it's
shorter.
It's just, it's clear that you've shortened the path, which is, inevitably going to yield better results at some level.
Yeah. And note that this wait seconds is applied twice, and this one is applied twice as well. So it's actually this in the original. If you would make that very rough comparison.
You've done good, Jip.
Yeah. I think this is gonna be it. I'm gonna stop the recording again.